Hi, welcome back to another Pastpaper breakdown. Today we're doing Core2 paper from the OCR board. This is the MEI qualification, so if you're not doing this paper, please turn away. If not, I'll be wasting your time. So Core2 is a relatively simple paper. All you need is answer booklet, which they will be provided, examination formula and tables, which will also be provided, and you can use a calculator in this paper. So yeah, as every single paper in this qualification, the maximum mark is 72 written here, so make sure to attempt every single mark. This video I'll be covering the first parts, so you can see section A is what I'm going to cover right here. So let us jump into the first question. Calculate the sum of from number 3 to number 6, 12 over r. So in this case, all we need to do is to substitute every single value of r that is required. This is called method of exhaustion, or just basic trial and error. So this is a 12 over r, and I want to have 6, and it starts with 3. So this is a pretty sneaky question, I have to say, because most of the people won't notice the 3 at the bottom, and so they will start from 1 to 6, which will be larger than the actual answer. So for good measure, I'll do the supposed actual method, which is I'll do from 1 to 6 subtract by from 1 to 2, so that you get from 3 to 6, if that makes sense. So from 1 to 6 is 12 divided by 1, and I've got actually a lot of 12s. So I've got 6 12s, and basically I'm just doing this. So I've got 6 different terms, and they are all aligned with this format. So all we need to do is to add them all up to get the sum of 6 of 12 over r, but we start with 3, so actually we will subtract the first 2 so that we get the bottom 4 of them. So in this case, I subtract the above sequence by 12 and over 1 and over 2, and you'll notice that this basically are the same, so you can just cancel them out because they're subtractions between these two rows. Might as well do a subtract sign here and a subtract sign here for good measures, and these are all adding on top because it's a sigma sign. So we add these, and because these two add together and subtract, they all get cancelled, so we do not need to care about these anymore. And now we have this massive piece of work. As you have your calculator, I would recommend you to type in all the numbers, or you can do a simplification before you do any calculations. And I actually recommend a later one because it removes carelessness from your calculation if your mental math is good. But if your mental math isn't that good, then I will choose to type everything into the calculator, and make sure that you do not type anything wrong. If not, you'll be sobbing after the exam. And so after a bit of mental math, that is the simplified fractions into decimal and numbers, and if you add them up together, it's 11.4. So that is the first, the answer to the first question, which is relatively simple. So let us get on to the next one. Alright, on to question 2. We've got find the integral of 3x to the power 5 plus 2x minus to the power negative a half. So that is a basic and simple integration. Let me copy that whole thing down onto my drawing board, and here it is. After some magic, the question has been transformed onto my drawing board. So now all we need to do is basic integration, which you have all learned, and I'll revisit this right here. So first of all, copy the whole thing, 3x to the power 5. Do things one term at a time. Make sure that the power, which is this 5, has add 1 onto it, and under it you want to do the same thing, 5 plus 1 as the denominator, and that will give you the first term of our integral. Now we want to have the second term, which is a 2x to the power negative a half. But this time we do the same thing as add 1 to negative a half. And at the bottom, same thing applies, so negative a half plus 1. That will be your denominator, and that will be the second term. And we are not done yet, because for every integration, you have to remember during differentiation we have omitted a particular term, which is a constant term, so we need to label that as C, just so we are not we are sure that we know there are something else that can be there. As long as it's a whole number, it will, well, as long as it's a constant number, which is not anything to do with x, then it can be differentiated to get the original question. Now we need to simplify the whole thing, so 3x to the power 5 plus 1, which is 6, so it's 3 to the power 3x to the power 6 divide by 6, and simplification can happen. 3 and 6 cancel to get you 2, so this whole thing is actually a half x to the power 6. So the next term, which we need to simplify, this looks a bit more difficult for most people, but it's relatively simple actually. 2x. Now the power negative a half plus 1, if you write that down and think about it, you'll know that it is actually positive a half, so it's 1 divided by 2, and in a term of indices that would mean a square root. So same thing applies to the bottom, negative 1 and a half, well, never mind, negative a half plus 1 is positive a half, so it's 1 half, and the last term is still c, it doesn't change, although I turned it into from a capital into a small letter c. Never mind, that doesn't change a big deal. Now we need to further simplify this, because dividing by a half means multiplying by 2. If you do your math well enough, you get 4. And so the answer to this question will ultimately be a half of x to the power 6 plus 4x to the power half plus c, and that is the ultimate answer for this question. So let's go on to the next one. And now we get into a particularly applicative question for integration, although it's really not integration, it's trapezium rule. It is very typical for the example to ask a question on something to do with the cross-section of some pipe, some mountain, or some particular river in this case. And it is actually quite simple to do, given that you make a sketch. So after I've prepared my information, I'll come back with you to do this question. Okay, so here I have the list that is given in the question. It wants us to find using 5 strips. So between these two values is 1 strip, 2 strips, 3, 4, and 5. So that is our trapeziums. And actually, let us do a tiny sketch for this. For a typo that I've discovered, this is not 1, this is 0, so I will fix this like this. Okay, so for these type of question, I recommend sketching the actual river for accuracy's sake. So for first, we have a depth which goes downwards. We have across the river, which is 7.5 that we want. So the first number is 0.6, it's about here, 2.3, it's roughly here, then it's roughly here, 2.8 is higher than that, and 1.8 is lower than the second one, and finally 0.7 is a bit higher than the first one. So this is the sketch I'm looking for. It's supposed to be straight lines, by the way. Actually, omit this line. This is a terrible idea. Right, so I've got these. All you want to find is the area between the x-axis and the line, so this area underneath. So by cutting out these 5 strips, you can find this. There are 2, 3, 4, 5. I think I messed up this one. It's right here. Okay, so there are 5 strips, each with width 1.5, because every strip is identical width. And there is a universal trapezium rule equation, which is the first value on the left, 0.6, plus the last value on the right, 0.7. Then you add twice of every single number in between, which is 2.3 plus 3.1 plus 2.8 plus 1.8, and that everything in here, which I will do a giant bracket for, and now everything here multiply by the number of strips the width of the strip, which is 1.5, and you divide by 2, and that will be your equation for the entire area underneath these amount of trapezium. So if you do every single strip independently, that will yield you the same results, but this one is a bit faster because you have factorized out this multiplied by the height divide by 2 part, and you just add every single value within the trapezium. So I'll do this real quick, and after a bit of calculator clicking, it's give us the answer 15.975, and in this case most people will round this number down. According to the question, according to the answer paper, they want anything to do with larger than 2 significant figures, which personally I'll do 3 significant figures, which will be 16.0, because 7 is larger than 5, and so you add 1 to 9, which makes it larger than 10. Well, makes it 10, and you grow another 1 forward, so that is a 3SF answer, or you can just leave it as 15.975. Down to question 4, we have curve y equals fx, and it gave you a minimum point. This question is a transformation question, and it is really the same as GCSE further math transformations. You just need to recall how to do them. So let us take a look. Okay, so in this question we are concerned about this particular point. When you do a multiply by 3 matrix, when you do a multiply by 3 calculation on a function, every single point have its y value multiplied by the factor. So the y value in this case is 5, and so the transformation will yield a non-changing x value and a multiplied by 3 y value, which is 5 times 3, 15. So that is the first part. This is a relatively simple question. Next up, y equals f2x, and in this case that 2 has modified the graph to have a higher frequency. It means it's more compressed towards the x-axis, and therefore instead of multiplying, you divide the x value. So in this, you'll have to do a divide by 2 of the x value, which you had 3. It's now 1.5 because of the division by 2, and the y value remains unchanged. So that is this question completed. Down to question 5, one of the most disliked questions of A-level is kind of sequencing, and these type of questions are a bit trickier because most of the time you'll have to do some sum of sequence, which I can see on question 6, but now let's finish question 5. The second term of a geometric sequence, given that the general equation is AR to the power n. So second term is 6, and fifth term is negative 48, and we need to find the 10th term, and also an expression for the sum of first n terms. And now here it is. Again, you need to do sum of sequences, and so let us get started. Okay, so let us tackle the first part of this question by finding the 10th term. In this case, all we have are these informations. We've got a base number a, and the next number is AR, and AR is 6 given by the question. AR squared is not known, AR cubed is not known, and the fifth, AR to the power 4, is negative 48. So to find this question, we need to do a bit of a division. So from AR to the power 4 divided by AR, we can get that A divided by A, which is 1, which we don't need to care about, and R to the power 4 divided by R, which is R to the power 3, which is R cubed, and that would equal to negative 48 divided by 6. Okay, so this is a good number because we can factorize it quite well. It is R cubed equals a negative 8. So we know that only one number can cube to 8, which is actually 2. And it's a negative 8, which means that due to the odd power, it is not necessarily imaginary, and therefore you can actually deduce that the cube root of negative 8 is equal to negative 2, and that is one part done. We have R, now we need to find A. How do you find A? Well, you know what A is here. You don't know what A is here, but you know what AR is. You just need to divide AR by R to get A. So A is equal to 6 divided by negative 2, which is negative 3. And so this is A and R done. And now we need to find 10th term. And if you notice, first term doesn't have an R, second term have 1 R, third term have 2 R, and you can deduce that the final version, the last number, will be AR to the power, well, the nth term rather, will be n minus 1 as the power, because the fifth is number 4, n is n minus 1. It's just how sequencing works. And now we want to find number 10, so we know that n is 10, and therefore the number we are looking for is A times R to the power 9. And in this case, all we need to do is to type into our calculator negative 3 times negative 2 to the power of 9, which gives you 1536, and that is our 10th term number. Okay, so second part of this question, question 5, we need to do a sum of sequence to 10, and we need to simplify it. So there is the equation that you need to remember for a geometric sum, which is a times R to the power n minus 1 over R minus 1, and that is the sum of geometric sequence, and you need to do a simplification of this question, and remember that a and r is a number, so you need to do actual calculations. So it's a negative 3 multiplied by a negative 2 to the power of n minus 1, and that itself is another bracket, and under it is a negative 2 minus 1. And here you'll notice that negative 2 minus 1 is actually negative 3, and so actually negative 3 cancels out another negative 3, and you are left with negative 2 to the power n minus 1. And actually you don't need to do any further working for this, because it's not the sum to number 10, it's the sum of n numbers of this sequence. So yeah, make sure to read your question before you do your questions. If not, you'll be doing extras or not answering the question. Now down on to question 6. The third term of an arithmetic progression is 24, and the 10th term is 3. We need to find the first term and the common difference, so a and r. Find also the sum of the 21st to 50th terms inclusive. So let us go on to find a and r. First of all, we have these two numbers that is given is 24 and 3, and all we need to do is to find a and r. So this is a simple equation. It is actually a simultaneous equation. This will equal to 24, and a plus 9r is equal to 3, and I'm pretty sure everyone here would be able to do this question to get r. Well, actually I'll do the calculation. 7r is equal to 3 minus 24, which is negative 21, and r will be equal to negative 3, and that comes a. What is a? So we use this part, 24 is equal to a plus 2r, so a plus 2 times negative 3, which is negative 6, is equal to 24, and therefore a will be equal to 30. So that is Ra and Rr. Now we need to find the first from the 21st term to the 30th to the 50th term, and that requires us to use the method that you subtract one part by another part. So unlike the first question, you cannot do exhaustion this way. If not, you'll be running out of time, and so you will need to use actual series equations. So due to the nature of this, it is a simple method, and I'll show you how. First of all, let us put down the equations. The sum of 50 terms subtract the sum of 20 terms. Because we start with 21, we don't need to care about number 20, so we subtract 20. And the equations are the same. It is a plus NR. The problem here is that if we use a plus nr in this equation, then we're going to get from a plus r as our first term, but we want a as our first term. So actually it is an n minus 1 r. And again, this is not particularly elegant. There are ways to get around this, and I'll show you. First of all, maybe you just want to sub in the r into the equation to make it a bit simpler. So in this case, these two will be the same. Here it is. And let us do the 50 terms first. So because this is an addition, first we need to simplify this entire thing. So it's a plus nr minus 1r. And we're concerned about the n's. We don't care about other constant term we call. So a and r are constants as we're found. So a minus r will be grouped together into a bracket, and you add nr as what we actually care about in this. And so you have a sigma of 50 right here, and something that you can do for a addition of sequence is that if it has nothing to do with n, then it doesn't change every single time. So you actually added 50 a minus r terms together, so it can be written outside of the sigma sign as 50 times a minus r. And on the other side, on the side where the sigma is, you need to write 50 of nr. And now here comes a thing that is standard series formula doesn't account for the r, but if you write every single term down, you can actually factorize this r outside of the sigma and multiply the whole thing after the n has been dealt with. So this can also be written as the sum r sum 50 n. And here we have this one thing that can be found using the standard series formula, or if you are have a good brain that you can remember, then you can figure it out right away, which is actually a bit like trapezium. It's the first term plus the last term, multiply the number of terms, and everything divided by 2. That is the equation for this number. So it's actually half of 50 times 51, which will be equal to, and I'll need my calculator for this one, 51 times 50 divided by 2, which is 1275. And remember to add an r on top of it. So sorry for the cut, I've been disturbed. So yeah, I was gonna say remember to add the r, because we did add an r in front of this term, so that this first term is actually equal to this thing, add this earlier part, which is 50a minus r's, and that is surprisingly the first part, so we can actually substitute the thing with this other parts. So we are done with the first section, and we can get that out of here, and we need to deal with the second half. Good thing is it actually is the same as this one, other than the a's and the r's are different. Well, other than the ands are different. So it is another part that is 20 a minus r. So that is our first part, and if you just use the same identical method that I used just now, then you'll get 20a minus r. Then you add another sigma of 20, and you multiply the thing by well, you have an r in front and there's an n, and again standard formula, you get 20a minus r's plus 20 times 21 divided by 2 is 210 r's. And so that is our second part, and you do the first part, subtract by the second part, and so I will rearrange this thing. Well, I'll just retype the whole thing here. So it is 50a minus r plus 1275r minus 20ar, another minus because obviously this thing is one term, and so this is one term as well, 210 r's, and that will be our sum, and all we need to do is to simplify this whole thing. So yeah, time for some calculator time. And after typing everything, you should be getting that thing equals negative 2205, and that is the answer for question 6. Now get on to question 7. Another one of the bane of the existence of exam students is logarithms. These are definitely one of the things that they most enjoy about, and I do mean enjoy. It is a very big pain, and let's get on to it. It doesn't look that complicated, as it's only 4 marks, so yeah, let us get into it. Okay, so in order to simplify these expressions, there are some logarithm laws that you can use to abuse them for your own benefits. In this case, you've got a x log base 10, which is just log because we live in a base 10 world, x to the power 5, and you can turn that power into multiplication to find that it is actually equal to power 5 log x, and that applies the same as 3 log x, which you just need to multiply not by a but by 4 log x, and now they are of the same base. Well, they are in the same base, but now they have something in common, the log x and the log x. You can do a simplification by just considering log x to be a variable and do normal algebra with it, which you'll get equals 5 plus 3 times 4 is 12, and that times log x and that is the simplified version, which is 7 log x, and that is the first part. The second part is here. This time I did label the log because it's base A, and anything base not 10, we need to label the base. So in this place we need to do a bit of simplification, so that the first term I do not think you can simplify much by itself, and so we take a look at the second one, and it can be factorized because as we have used on the left the power law, you put the b in front of the log, so it's a b log base a of a. And another law can apply right here, because anything, any log to the log itself, which say log 10 tenths, is always 1, and it will always be 1, and so log AA will be 1. It applies the same as log BB, log CC, and stuff like that. So we can just remove that, and we still got log A 1 minus B. And now log A1 is actually another index. Anything to the log of 1, if I write this thing into an equation, say log A1 equals C, and that if you turn it into the correct calculation method, or you turn it into the simple and basic way to write logarithm, is actually C equals to A, never mind, it's actually 1 equals A to the power C, and this is in the laws of logarithm as well. So this can only mean one thing: C have to be 0, because only when a number to the power 0 will equal 1. And so log A1 is actually C, which is have to be 0, and so this is actually 0 minus B, and therefore the answer is negative B. So that is the answer for this question, and let us move on. Now we have some trigonometry equations, and these are quite simple by themselves. So you will have to use some identities of trigonometry by the names of sine square theta plus cos square theta equals 1, and sine over cos equals tangent. And now let us get on to this question, and remember, whenever it gave you a for something is larger than or smaller than another thing, you have to give answer in that region. And remember to turn your calculator to degree mode, because this question requires degree instead of radians. And if you gave radians, you'll be judged mistake. You will be wrong, essentially. So make sure you have the right mode. Okay, so to do these type of questions, first of all, you want to make sure that everything is in the same format. So you don't want to have sine and cosine at the same time. You want to have only sine or only cosine. in this case, I'm going to turn 5 sine squared into something else. In this scenario, it is advisable to turn this sine square into a cos square by way of, because you know sine squared plus cos squared is 1. So sine squared plus cos squared is equal to 1. And in this, we have 5 of sine square, so you actually multiply the whole thing by 5 and you get 5 sine square plus 5 cos squared is equal to 5. And if I want 5 sine squared, you subtract 5 cos squared from 5 and you get that is equal to 5 minus 5 cos squared. And this will be 5 sine squared, and you just put that into the equation, so 5 minus 5 cos squared equals 5 plus cos. I'm not going to type the theta because it's a bit of work and I can't remember the command to do it anyways. Now we can rearrange this thing. We know that 5 and 5 cancels, so we just remove them from the equation. This negative can move to the right, and so we'll get that 0 equals 5 cos squared plus cos, and that is what we are looking for. And remember there's a plus 0 here, just so it looks like a quadratic. Now we need to factorize this stuff, and this is not entirely easy, is it? You will need to use the quadratic equation, and so the first thing will be -1, negative b, then you do a plus or minus, which again I can type plus or minus, the root of b squared, which is 1, minus 4ac, which is 0 because c is 0, and that all divided by 2a, which is actually 10, and that will be our answer for what cosine theta is. But we want to find theta, so we'll soon need our calculator, but let's first factorize this stuff. Root of 1 is 1, so it is a -1 plus or minus a 1. Actually, it's a root of plus or minus 1, which it's given. Never mind. Divide by 10, which we know is 2a. Now, this is a plus or minus, so it's either it's either 0 or minus 2 over 10, which is 0.2. And we have two cos theta value, and now we do an arc cosine 0, which is a 90-degree, and they are negative 0.2, which is 101.53. So we've got two values right now. we need to make sure that we find every single value, so we have fulfilled the answer criteria. And every time doing these type of sine and cosine, I highly, and I do mean highly, recommend sketching a graph depending on what you are actually using. You sketch different graphs. In this case, I'm sketching a cosine curve. This is +1, this is -1, and 90 degrees right here. Never mind, that is 180. I cannot do graphs. This is 90 degree, and this is 270. This is 360. And so now after we have found this curve, we can find other values of that answer. So for negative 0.2, there are two values corresponding points, so there are another value right here. To find this the other value, you do 360 minus this number, because say 101.53 is like here, and because this is mirrored at 180, if you subtract the maximum by the same number, you'll get to the same points on the curve. So another answer to this question will be 316 subtract by that answer, which is 258.46. And another one will be opposite 90. Again, you do 360 minus 90, which gives you 270. And so you have 4 answers for this question. And that will be it for this one. Let's get on to the final question on section A. So Charles has a slice of cake, and it is a sector, and the radius is r, and the sector angle is pi/6 in radian. And whenever you see that, make sure to turn your calculator mode to angle unit radian, and that will make sure you get the correct answers. So he wants to give half the slice to Jen, and he makes a cut across the sector, and to show if it is half a slice, the A will have to be r root pi/6, and that is a bit of graphical calculations. First of all, let us find the actual area of this cake. For the actual area of the cake, because the radius is r, the sector is pi/6, and I do not remember what pi is again, so I'll do this. Pi/6 is what we're after. Okay, so we have the radius of this sector. If I have a circle drawing tool, and I do, I've got a circle and I need 2 lines for a sector. That is a sector right there, and I want to do some art, so I'll pause and come right back. Okay, so I feel like I've done a good enough job of drawing a pie. Yeah, that's why I don't do art. So the area of a sector is pi r squared, and that multiply by the theta, which is pi over 6, so I'll just say angle divided by 2 pi. And the reason that radians are useful is because you will get 2 of the pi's and you can cancel them out, and so you're left with something relatively simple. The problem is, most of the time, the angle unit is in terms of pi, which makes it less ideal. So it's actually r squared times pi over 6 times 2 divided by 2, that is. And so it is pi r squared over 12. So okay, so now that is the area of this sector. Now he wants to cut this thing in half, and so by cutting it in half, you want the area to be half, so it is multiplied by another 1 over 2 to get pi r squared divided by 24. That is the half section of the cake that we want. Is it a cake or a pie? Doesn't matter really. So let's get these away, and that's all we need to know. Now, how do we find a triangle? This time it's a triangle because we have sectioned off half of the pie by chopping it like something like this, and we get this thing, and this angle is still pi over 6, and we need to find this length, and we want it to be in terms of this. So let us find the area of this in terms of A. The area of a triangle is using sine rule is half AB sine C, which A and B are the same because it's isosceles. A and B are A, so it's A squared times a half, which is that, half AB, then you do a sine the angle, which is pi over 6. And the notation here is a bit bad because it's computerized, and if you draw it out, it's less confusing. So now let's do a bit of calculator pressing. Okay, so pi over 6 is a half. Sine pi over 6 is a half, so it is 1/4 of A squared. And now we need to do it so that this area is equal to half a pi's area. And so we need to put A in terms of R, and we do rearrangements. So let us move this down here for good comparison reasoning. Okay, so because we both have a fraction, we want to multiply both sides, and we want things in A in terms of R, so we multiply both sides by 4 to get that A squared is equal to pi R squared divided by 6. and now we root everything, and to get A is equal to R, because this can be individually rooted, so it's R individual, then root of pi over 6. And yes, I have took the time to draw out the actual notation so that you know how to write this thing in terms of exam. So that is actually the same as the question required, and so that is it for this part, section A paper. And yeah, that's it for this part, and stay tuned for section B on next video, and I'll see you next time. If you find this helpful, make sure to let me know what to improve in my video by giving me a comment below, and I will see you again next time.